Hello, this is Professor Lily Morningstar at the College of Southern Nevada. If you're watching this video, you're in my CIT173 Introduction to Linux class. The lesson 3 is covering Linux file system topic. The goal of this lesson for you is to understand Linux file system hierarchy. By the end of the lesson 4, you should be able to understand Linux file system hierarchy, specify absolute relative path, determine the working directory, create copy, move, remove, generate links for files and directories, search files and directories, and officially run commands. Let's talk about Linux file system as a big filing cabinet. The cabinet itself is a root directory presented by /. Each drawer is a subdirectories of the root directory. Inside of these drawers are binders. These are child directories or second level directories. Directories or folders inside of them are third level directories. We will call them subdirectories. And any directory that above we will call a parent directory. So subdirectory is a child directory. There could be multiple child directories, and any directory above in the hierarchy is parent directory. Look at this slide. I found this visual representation of Linux file system online. It was a long time ago, so I do not save resource who it came from. But my big kudos to the creator. It perfectly demonstrates each important second level directory and third level directories that important for you to know. In Linux, everything is a file. Text is a file, image is a file, sound is a file, and directory is a file. Anything can be opened and looked at as a text. Directories is basically Linux version of folders. If you are a Windows user, you more know this as folders. And pathways, it's like a roadmap that tells the computer where to look for specific directories or specific files. An absolute path always starts with the /. That means from the root. And then you specify subdirectory of the root, subdirectory of that directory, and each level of directory. Just like Russian nesting doll, one inside of another. Where relative path doesn't really need /. With relative path, you can work with files and directories that are inside of your working directory, right where you are. And if they are saved in that place in that directory, you can address them without /. Root is administrative user. That's the name for administrative user. It has full permissions to the entire system. There are different types of users. We will learn about them later in the course, but each user that like regular users have individual home directories, and they are going to be unique to their shell settings, and they're going to be isolated from each other. Only root can access individual user user directories, or in that matter make any changes to them. However, different users should not be able to access each other files that inside of their home directories. Every user has a primary group that named after that user. Groups allow us to work on some permissions, who what can do with specific files and directories. But some groups created to unite users based on their needs. Permissions, again, we will learn a little later. But in a file system, we can have permissions to control access to modify certain files. That helps to keep your information safe. Main permissions are read, to have an access. You see R for read. Write is, you see W, right? It means modify. And execute. Execute, you see as a X permission, X letter, and it means to run a script. If it's not just regular text file or directory, if it's a program that needs to be run. Linux has organized structure that we call File System Hierarchy Standard, or FHS, which provides consistent and organized structure for storing files, directories. Knowing the structure helps users to locate and organize data efficiently. So make sure you spend some time with that slide that I showed you earlier with the file system hierarchy tree. First of all, it helps us to have predictable locations, like key system components and user data stored in predictable locations. For instance, system binaries always gonna be in /bin directory. Configuration files in /etc. User home directories in /home. And variable data, the data will be changing constantly in /var. Knowing these locations will make your navigation in Linux file system and troubleshooting is a lot easier. It's easy to navigate file system when you're understanding this hierarchy. The whole hierarchy facilitates this easy navigation. Users can quickly move between directories using commands like cd, find, path to files and directories, and commands like pwd and ls. This allows efficient commands usage. Many Linux commands operate on files and directories. Knowledge of the file system hierarchy helps users effectively use commands like cp for copy, mf for move, rm for remove, and other loading to better file management. System administration must be familiar with the file system hierarchy to perform tasks such as illustrating software, configuring services, managing user accounts, knowing where to find places, essential for maintaining well-functioning system. Linux file system is called journaling file system. It's a type of the file system that maintains a log or journal of all changes before applying them to the main file system. That helps to ensure the integrity and consistency of the file system, making it more robust and resilient in the face of unexpected events like system crashes, power failures. The journal is a small dedicated area in one like disk space on a disk space where the file system records and changes. It intends to make and this log or journal contains a record of the operations that will perform on each file system as creating, modifying, or deleting files. In the event of sudden power loss, system crash, or other unexpected shutdown, there is a risk that file system might be in inconsistent state. Journaling helps maintaining the consistency of the file by providing way to replay the recorded transactions and bring the file system back to the consistent state after such events. Journaling ensures that file system operations are atomic, means they either fully complete or have no effects at all if operation is interrupted. The journal can be used to recover and complete the transactions on the roll back in maintaining the integrity of the file system. Because the file system changes already recorded in a journal, the recovery process after the crash of the power failure is faster. The file system doesn't need to undergo like lengthy consistency checks, as a journal provides a quick, efficient way to replay the transactions before and restore its consistency. Common journaling file systems used in Linux include X3, X4, XFS, and JFS. Each of these file systems implement journaling to varying degrees, provide different features and performance. While journaling increases the reliability of the file system, there is slight performance overhead due to the additional work of maintaining the journal. However, the trade-off between reliability and performance generally considered worthwhile, especially for critical systems. Let's learn about some standards of the file system. Obviously, you saw this schema earlier when I showed you that tree representation of Linux file system, but let's look at it again. Make sure you actually learn each individual node, which another term can be used for directory, and its connections, how they are linked to each other in the file system. So the first level directories that we see is bin, where essential command binaries, boot loader files in the boot, /dev device files, means if you attach any device like printer, it will appear inside of this directory. etc, where you can have all the configuration files, /home. Here, all the users, local users on the system will have their home directories. /lib, where all the shared libraries will be. /media, sometimes it's /mnt together, but it's a mount point. We will discuss this in a moment, where you will be attaching or system will be attaching storage devices. /opt, optional. /root, don't be confused with the root directory. So the root directory is our top level directory. Remember the filing cabinet, right? Analogy. But /root is the home directory of the administrative user whose username is root. /sbin, where the system binaries are, like setting files for system. /tmp is where the temporary files, anything saved there, will be removed if you reboot the system. /user, they're really important user related settings and so on. So for example, user bin, where the user command binaries, and the bin right here at the second level directories is actually a link to this user bin. We'll learn about links at the end of this lesson, but what it means basically, it's created higher level hierarchy as a link to easy and faster access that directory. In /var, you can find all the variables, something that's changing constantly when you're working on system. One of the most important directories you should know is var log, where you can find all the logs for the system. Okay, let's move forward. Let's look at different navigating commands. Extremely important for you. Memorize, practice them. I listed some examples for you here. So first, let's look at the symbols. Tilde symbol represents your home directory. The $sign symbol at the beginning of your command line prompt, where you will be typing your command, means you're a regular user. If you see a hashtag instead of $, most likely you logged in as administrative user. PWD stands for print working directory. This command will show you where you are currently in the file system. Sometimes it's not easy to identify where you are, exact path to where you are, if you've been working for a long time and you already forgot how you got there. Who am I? Another command that needs to be remembered by you. Sometimes users, if you especially don't have this at the beginning of command prompt that tells you who you logged in as user, will tell you exactly who you are. So if you're a student user, it will tell you student. If you are a root user, it will tell you you are root. CD stands for change directory. This command will allow you to go from one directory to another directory with ease. You can use cd command without anything following it to get to back to your home directory from whatever you are. Let's just say you've been working in some directory, then you move to another directory, and you need to go back to that previous directory where you worked previously. You can type cd space dash, and it will take you back, sort of like in a browser, the back button. If you need to go one directory up, which means to the parent directory, you can type cd space dot dot, and that will take you to the parent directory, or in the file tree hierarchy, one directory above. If you need to go two directories above, so parent directory of your parent directory, then cd dot dot / dot dot. Same way, you can actually move in between sibling directories. Sibling directories means the same level in hierarchy directories. So let's just say bin subdirectory of the root directory. And you currently somewhere like in a library directory in the / lib. So you need to go to bin. You can type cd space dot dot / bin, which means first go into the root directory or directory above parent directory of the currently working directory, and then jump into bin. If you need to navigate to any other directory, you can choose to use with cd full path, or we call it absolute path, or relative path. The difference between absolute and relative path, that relative path doesn't start with the forward slash. It does not have to include all the subdirectories on the way to get to this specific file or directory, and only can be used if that file or directory that you're trying to access, well, with cd is obviously directory because you're changing directory, that is inside of your working directory. If you see something like this wavy line, sorry, I moved forward, but if you see wavy line and forward slash, that's a shortcut to get you to your home directory. Now let's talk quickly about storage management concepts. So what you need to know is basically the name of the file system that Linux use. So Red Hat Linux use extends file system. Like most Linux systems, it's named ext4, which means extended file system version 4. There was 3 more versions before this one. And how to understand what it is, basically like Windows has NTFS file system, and NTFS file system in Windows and Linux file system ext4, they're not backwards compatible. I mean, they're not compatible with each other. So you need to know this. And that's why using file allocation system or FAT is one that can be working with both operating systems. Actually, not just both, Mac OS as well. And the current version is XFAT. Before that, it was just FAT, then FAT 16, FAT 32. Now it's XFAT that can be used with the thumb drive or another external storage devices with the large capacity. And you can operate with the large file sizes too. The enterprise of the server file system is called global file system that allows to serve multiple users at the same time. Modern Linux file systems identify connected external storage automatically and place mount points in /MNT directory. However, in some circumstances, you need to specify the spot where this external storage can be accessed by user. This would be called a mount point. Any attached storage device in Linux will be called a block device. You can access this with the command lsblk. I previously skipped the slide accidentally, but that last command I was going to introduce you, actually ls command. Ls stands for list, which means you can see the content of the directory you need to see. So this one is similar. It's lsblk, means list block devices. Understanding partitions is very important. So Windows, Mac OS, Linux, they all have similar concepts of the partition. Let's just say you have a large storage drive and you can divide the space on the storage into chunks, compartments that would be recognized by the operating system as the separate storage. Each portion have its own system and it can be dedicated to the specific needs or hidden from the regular users, different file systems, and so on. Logical volume is very similar concept to the partitions. However, with the logical volumes, you not just can split storage into multiple isolated compartments, but also unite different storage devices into single storage. So you already learned some navigational commands. Now it's time to learn about commands that will allow you create, use, delete, and files and directories, or make links. Remember I mentioned links earlier. It's like a shortcut to access them. So first of all, let's look at expansions. You have this table in your book. Make sure you spend some time memorizing it. Make sure you spend some time practicing, because this will make your work on Linux a lot faster and a lot easier. Now let's go quickly over each command. So first we have touch command. Touch command will allow you to create any type of file that it's like empty file. It has no content in it. You don't even have to specify what type of file it is, because everything is a file in Linux. But it's like a dummy or template for the future file, maybe, or like namespace holder for the future file that you will work later. Make dir stands for make directory. As you can guess, it's to create the directory. CP stands for copy. Will help you to copy files, directories, or rename files and directories. Actually, you can look at the examples and try some of the examples from the book on your Red Hat lab environment. MV stands for move. Similarly to copy, you can use it to rename files and directories. However, with copy, you will have an original and a copy version of this file or directory with the new name or original name if you keep the same name. With move, you're actually moving it from one location to another location. RM stands for remove. With this command, you can remove files and directories too. You need to be careful with this. Once you remove, you cannot restore file or directory. Next command, rmdir, similar to mkdir. It means remove directory. It will allow you to remove only empty directory, the directory that has nothing in it. If you need to remove directory with the content, you will use rm command, but you will use option R, that stands for recursive, means remove this and everything inside of it. Now, let's look at these two commands. Sometimes you need to create a shortcut to a file or directories so you can easily and faster access from whatever place you need to access. Links are a similar concept to the icons on the desktop. It helps faster access folder or file or program. You can use ln command to create a hard link. So hard link, it's like another file name. It's almost like exact copy of the file. But the difference between hard link and a copy, that copy creates two separate files. So if you make changes to a copy file, the original file will not have these changes. Hard link is pointer to the data. So no matter what changes done to the link or to the original file, these changes will remain in both. So think about hard link as the pointer to the data on the storage. Um, any changes, as I mentioned, will affect. However, the benefit of the hard link that if you delete accidentally original file, the hard link becomes an original file. So since it's pointing to original data, it will have all the changes that been done before to that file. You can use hard links only with files, not directories, and only within the same file system, which means if you have separate the partition or separate logical value, or maybe even a block device attached, you cannot create hard link between them to the files. For that specific reason, uh, symbolic links was created. Another we can call it soft link. And the easier way to remember that it's LN with option S. So you will be creating a symbolic link. And the best way to describe this, it's a shortcut, but it's more like a hyperlink on the web, like on web pages. And instead of pointing to the data on a storage, inside of the storage, it points to the file, to the original file. So soft links can be used with different file systems. Soft links can be used with files or directories. Soft links have a lot of benefits. The problem, if original file deleted, soft link is not going to become an original file. What's going to happen? The soft link will be broken. You will no longer be able to access the original data through the soft link. Now, really important for you to know these commands. If you're searching for something, some files, first of all, locate is one of the easiest. This command can search for files based on the database that has like file names and everything at the moment when you put it into the system. If you had some changes done during your work, this database will not be updated automatically. So you need to run a command update db first, and then you can use locate file to find location of the specific files or directories. Where is similar, but it returns location of the binaries. Binaries, remember I told you it's a program settings files. Find is very powerful. It's one of the most powerful search tools you can use, and it will help you to find the file. If you don't know like specifically name, you can use expansions during your search. You can find file by location, by the size, like for example you're looking for specific size, or you're looking for the files that like you don't remember the name of the file, but you know you created this file like 2 days ago. So you know, not exact, but maybe approximate time and date. And based on this information, you can use find command to find. Make sure you use man pages to learn about all these commands and what options can be used with them. Next command is grep, another really, really useful and powerful command. But it's more like a filter, not used on its own. It's more like a filter that allows you to grab specific strings of text. So sort of filter out based on a searched word. Okay, so we're done. This lesson was long and hopefully it helped you to understand Linux file system better. And now you're ready to be a Linux user. If you still have questions, you know where to find me. Okay, bye bye.